All right, gentlemen, I'll be right with you. Still just taking attendance. Okay. Let's see. So no major announcements. This is the top of week 11, right? I think I'm gonna go ahead and suppress my audio so I can focus. Feel free to you can unmute yourself, but to get my attention, you probably want to use the chat first or like raise your hand. Um, but this is the top of week 11. So what that means is that next week, probably, hmm, I'll probably go ahead and make a start on Monday. I usually have the exams open up on Wednesdays, but I'll probably open the exam Monday morning. I give you a full 7 days to work on exam 3 for full credit. Let's see. So we'll have exam 3 next week over chapter 2, so sections 2.1, 2.2, and 2.3. And then I think we have 2 more sections after that, and then we're going to be moving into the finals. I know we have the Thanksgiving holiday coming up. This is going to be over in the blink of an eye. We only have about a month remaining after this week. It'll be over very quickly. I hope everyone had a good weekend. You were able to get some work done, enjoyed your time. I just want to say this, like, we only get like, what is it, like 40,000 winks or whatever. So I just want you to be like cognizant of how you're using your time. Like, I mean, still work hard and do what you need to do, but take your time to enjoy your time because certain all these moments in time you only get one shot at each moment, right? So these moments don't come back around. Even though the date repeats, it's not the same year, right? So we don't get those. Every moment is unique. So just take advantage of it. Maximize your time, do what you need to do, but in the same token, you know, just be aware that we're limited in this incarnation, in this form, you know, we're limited to like 40,000 winks or something like that. So anyway, let's see. So this week, what I wanted to do, we're moving on to the last section. So the section of 2.3, the last section of chapter 2, which is 2.3. We're just going to go ahead and get the party started. All right. So I forgot about this pen. It should be okay though. So chapter 2 is again, it's covering polynomial and rational functions. And so today we're looking at section 2.3, dividing polynomials and the rational zero test. Again, if you have questions, feel free to type in the chat or just get my attention and we can discuss anything that you need to discuss. Also, if I haven't responded to an email, good. I'm just not good with emails. I mostly use emails just for record keeping, and I try to use class time like to address any kind of issues. This is generally how I do it. Just because when I'm not with you guys, I'm just ripping and running, you know, maximizing my personal time as well. So, a lot of things, I can't really think of things that I share with you guys that I don't. I'm really just talking to myself and just letting you in on my inner thoughts. That's all that I'm really doing. Okay. So section 2.3 is regarding dividing polynomials in the rational zero test. So some objectives here, we like to learn the division algorithm. We want to use the remainder and factor theorems and use the rational zero test. Okay. So first, let's see, we have like some terms. We have a polynomial factor. A polynomial d of x is a factor of a polynomial f of x if there's a polynomial q of x such that f of x equals d of x times q of x, right? So again, remember, factors are things that are multiplied and divided, and terms are things that are added and subtracted, right? So one polynomial is a factor of another if that polynomial times a second polynomial equals a third polynomial, right? So again, factors are things that we multiply and divide. So let's take a look at this division algorithm. If a polynomial function f of x is divided by a polynomial d of x, where the d of x is not 0, there are unique polynomials q and r such that, let me do like this. So f divided by d equals q plus some remainder, right? Now, if we were to take this and distribute d of x on both sides, like if we multiplied this side by d of x and distribute the d of x across here, right? If we basically multiply the left and right side by d of x, then we get this one down here, right? So let's see. Because if you multiply this by d of x, you see it there. And then this by d of x, you see it here, right? So I feel like this one is a lot easier to remember than the other one. I mean, but honestly, this first line is the way you're going to see it, right? So if you have one polynomial divided by another, right? We're using d. You can kind of think of it like the divisor or the denominator, right? So one polynomial divided by another equals some quotient, that's basically your answer, plus some remainder over the original divisor, right? So again, the f of x, the dividend, the original polynomial is going to be that denominator times the answer plus a remainder, right? So two different ways of expressing the same thing. But the way, when we're kind of working these questions, it generally takes on this form. Some polynomial divided by something equals an answer plus a remainder, okay? So either r of x is the zero polynomial or the degree of r of x is less than the degree of the denominator, the divisor. Okay, let's see this in action. So using long division and synthetic division to find, let me go like this. Using long division, give me a moment, like that, and that should be enough space. Using long division and synthetic division to find the quotient and remainder when this polynomial is divided by this. We'll start by doing long division. Okay, let me get a copy of this. Let's see, I can get rid of that one. I need it from here. This is what I need. Okay. Come on. Oh no, you're messing me up. There we go. Okay. So we have this polynomial. Let me get the student. Make sure I got them. Okay. All right. So we have this polynomial is divided by this one. Okay. So first, let me see. So we got x to the 4, 3, 2. So now notice that we're missing x to the power of 1, right? If you look at the exponents, right, we have x to the power of 4, we have x to the power of 4, x to the power of 3, x squared. We're missing x to the 1, and then we have x to the power of 0, right? So we need to fill in that missing exponent, right? We need to account for that missing exponent. So now if we're going to do long division, let me see something. So that dividend and the divisor, right? So when that dividend is divided by that divisor, so we're going to say x plus 2 divided into, now we have this 2x to the power of 4. Hang on. That should be fine. 2x to the power of 4 plus x to the power of 3 minus 16x squared. So now, what I'm going to add in is this guy, plus 0x to the power of 1, right? Just be aware that that's to the power of 1, plus 18, right? So now, this process is very similar to like regular long division, right? If you have one number divided into another, you list out what is the highest number of multiples that's in there, then you multiply, you subtract, you get a result, and then you bring down the next component, right? This is a similar procedure. So the first thing we want to do, we want to take the first term of the dividend divided by the first term of the divisor, right? So we're going to say 2x to the 4 divided by x. So if you say 2x to the 4 divided by x, we get what? 2x cubed. So I'm going to put the 2x cubed above the x cubed. I'm going to put it right here. 2x cubed, right? So then next we want to multiply, all right? So we're going to say this times this and put our answer here. All right, like that. Okay. So if we do this, 2x cubed times x is 2x to the 4. 2x cubed times 2 is what? 4x cubed, right? So then the next step that we would normally do is subtract. So we want to subtract this line, so we need to distribute a negative. So if we distribute a negative, this becomes negative and this becomes negative, right? So just like with regular long division, we subtract that line. So now notice that those first terms subtracted 0, which is what we want, and then 1 minus 4, that ends up being negative 3x cubed. Next, we bring down the next term. So then that negative 16x squared comes down. So now we repeat that process. We're going to say the first term divided by the first term. So negative 3x cubed divided by x is going to be negative 3x squared. Right? So then we put that answer here, negative 3x squared. So now we repeat, right? So we take this negative 3x squared times this whole thing, the answer goes here. So that times that, the answer goes here. Okay? So then negative 3x squared times x is negative 3x cubed. Negative 3x squared times 2 is a negative 6x squared, right? Again, now we need to distribute a negative. We're going to subtract. So if we distribute a negative, I think both of these become positive. Okay. So the first term adds to 0, which is what we want. Negative 16 plus 6 leaves us with negative 10x squared. All right. Okay. Hopefully you can see, and then I think we repeat it. So the next one comes down. Okay. So we're going to say plus the 0x. Okay. Repeat the process. So we're going to say negative 10x squared divided by x gives us negative 10x. So we'll put our answer here, negative 10x, right? And again, this purple part is very easy to miss, all right? If you really wouldn't know that on your own. Someone would have to tell you about that. This is not like intuitive, right? So then now we want to multiply negative 10x times this. The answer goes here. Okay, we're multiplying. So then negative 10x times x is negative 10x squared. Negative 10x times 2 is negative 20x. All right, now we subtract again, so we got to distribute our negative. That changes both of these signs. Okay. Again, that first term adds to 0, which is what we want. 0 plus 20, of course they want to come and do yard work while I'm trying to stream. But that's how life goes. So I think one of the most powerful things in the experiences that I've had to overcome, doing what I can with what I have, and then just accepting the things that are out of my control. Like sometimes I can be like a perfectionist and like be really, really hard. And then it's like, it's frustrating because, that helpless feeling that there's nothing you can do. You've done everything you could do. But I take solace in knowing that I did everything that I can do and like feeling like I didn't just not do anything. I did what I could do and then I let it go. But that ability to let things go, I swear it saves my life. Because, when you don't let things go, I mean, it can really be like debilitating. So it's, again, my recommendation. Now that's just for happiness. Some people don't care about happiness. And I saw this thing that was like, I watched this movie. Man, I've been watching these movies like on Netflix. They've been really good. Like, it started with Squid Game, so that was a good one. And then, but it was this weekend I watched not the Yin Yang Master. Oh, this movie on Netflix called Super Me. Basically, this guy goes into dreams, and then he realizes that like he's having nightmares, he's getting attacked, and then but when he wakes up, he can bring something back from the dream. So he was bringing back these antiques, and he became rich, but he wasn't happy. You know, daggone it. Okay, I don't want to spoil the rest of it, so I'm gonna leave it there. But it's a good movie. I just like the moral of it. In case you do want to watch it, yeah, it's called Super Me, but that was a good one. And then the other series I watched movies was called Yin Yang Master. So it's like Yin Yang Master. It's two of them. It was weird, like because they released them at the same time. So I think that plays into the whole Yin Yang thing. It's kind of interesting. Anyway, and I wasn't sure which one was first, so I just watched them both. The second one I'm having a little hard time getting through, but it's still actually really good. The message is good. The action is good. A little bit of love. It's good stuff. It's a good watch. Okay, let's get back on task. Just chatting. So bringing down to 18, right? Let's see. I think we need to divide. So we're going to say 20 divided by x, right? 20x divided by x, that leaves us with 20. So we're going to say plus 20, right? Okay. So when you line up your answers, the like terms, that kind of helps you to see when to stop. You know, you generally stop whenever your answer is of a lower degree than your dividend, your divisor, all right? So when it's a lower degree than this guy. That's interesting. Okay, so then let's go ahead and do our multiplication. So 20 times x gives us 20x, and then 20 times 2 gives us what? 40. And we still need to subtract. Okay. So then the first term adds a 0. That difference is going to be negative 22. 22, right? Notice that the degree of this is less than the degree of this, so that means we stop, right? So then the result here, the result ends up being 2x cubed minus 3x squared minus 10x plus 20 minus 22 divided by x plus 2, right? So this is the quotient with the remainder. This is the result with the remainder. Let me look at one other thing real quick. Yeah. So we finished in like this form. Okay. So that's us doing it with long division, right? There is another way, all right? We did all that with long division. Another technique is called synthetic division. Whenever you have a polynomial divided by a linear binomial, whenever you have a polynomial divided by something that looks like this, we can take the 0 from this binomial and do synthetic division, all right? So if we're dividing by x plus 2, synthetic division looks something like this. If we put negative 2 into our chair, and then we take the coefficients from the dividend, right? So then we would take the 2, the 1, the negative 16, the 0, and the 18, right? You still need that placeholder. Okay, I'm kind of running out of space, but I think we can make it. And you put this like this, okay? So first thing is the 2 just comes down. This 2 just comes down. The first term just comes down. Now on the diagonal, we multiply. So whenever we're going on the diagonal, we multiply. Whenever we go vertical, we add, right? On the diagonal, we multiply. On the vertical, we add. So now we say, if we say negative 2 times 2 gives us what? Negative 4. So negative 4 goes here. Now vertically, we add. 1 plus negative 4 is negative 3. Now diagonal, we multiply. Negative 2 times negative 3 is a positive 6. Now we add. Negative 16 plus 6 is negative 10. Multiply is going to be a positive 20. Add is positive 20. Multiply is negative 40. And add is a negative 22, right? So since we started with a degree 4 polynomial, this is called like the depressed equation, I guess. But since we started with a degree 4, that means this is now a degree 3. So then we go x to the third, x squared, x to the 1, plus that minus that over, what was it, x plus 2, right? And you see the results are the same. So we saw two different ways of getting the same result. Now, we don't always have the luxury of doing synthetic division. Sometimes we have to do synthetic division. Sometimes, what is that? Sometimes we have to do synthetic division. Sometimes we have to do polynomial long division. Okay, let me just. Just trying to get you to see that these are the same. Okay. 2x cubed, 3x squared, minus 10x plus 20, minus 22 over x plus 2. Okay. All right. Let me go paper. Get rid of the lines. Let me see the time. Okay. So here you see long division. All right. I think you can see it worked all the way out, similar to what we did. And they even have the placeholder. And then synthetic division, again with the placeholder. So the result is the dividend divided by the divisor equals the quotient plus the remainder. Okay. I mean, it's okay. I'm deciding if I was going to give the student attendance credit, but it's fine. Okay, keeping it moving. So if a polynomial is, let me see, if a polynomial function is divided by a linear binomial, then the remainder is given by this, right? Let me see, if a polynomial is divided, so basically what we just did, so if a polynomial function is divided by x minus a, then the remainder, okay, so if you take that 0 and pass it, like evaluate the function at that 0, then the answer is going to be the remainder, as if we did polynomial long division, right? Or synthetic division. Find the remainder when this polynomial is divided by this, right? So what this is saying is if we evaluate this function when x is 1, that'll give us the remainder when we do the division, right? Instead of doing the division, we can just test the 0, right? So what the remainder theorem was saying, if in this case, if we do f of 1, right, we're going to have 2x to the power 5, x is 1, minus 4x cubed, again, x is 1, 5x squared, 7x, my dog is snoring like a grown man over there, and she's a little chihuahua. Just a little bit, she's like, so funny. Okay, let's keep going, all right? So this first term is 2 minus 4 plus 5 minus 7 plus 2. Let me see. I think these cancel, right? Because these add up to 4. Minus 4 goes to 0. So the final result is negative 2. So our claim is that when we do long division, the remainder is negative 2. Right? Yeah. That's what the remainder theorem says. So if we were to say that dividend divided by that divisor, when we do the division, the remainder would be negative 2. Right? But that's the remainder theorem. There's a correlation between evaluating the function at the 0 of the dividend of the divisor and the remainder, right? I know that's a mouthful. I couldn't think of a more elegant way to say it, but you know, you see it typed up here. Okay. So let f of x be this polynomial. Find f of 3, right? So now we could plug in when x is 3, right? So this is still the remainder theorem. We could plug in when x is 3 and you get a result. For the sake of time, let me think. Do I want to write that? I don't really want to write that. 9 times 9 is 81. Okay, let's do it. So say there's two ways we can do this. We can just do it brute force, right? Just do it directly what they're saying, and let's just do that and see what happens. So if we say f of negative 3, right? That's going to be x to the, you got to do this, x to the power of 4 So that's going to be, what is that, negative 3 plus 3 times negative 3 cubed minus 5 times negative 3 squared plus 8 times negative 3 plus 75. Let's just do it and see what happens, right? So then negative 3 times negative 3 is 9 times 9 is 81. So that first term is 81. 9 times 3 is 27. That's going to be a negative 27. So I think that's ultimately going to be what? Negative 81? Because we have an odd number of negatives there. So it looks like those first two terms cancel each other out. 9 times 5, this is going to be a negative 45. 8 times 3 is a negative 24. Hopefully I haven't made any mistakes. Plus 75. So again, I think that's fine there. What is that? 69. So then 6. Oops. So we get a result of 6 there, right? So when we just plugged it in, we got 6. Now instead of doing it that way, we could use, let me think about it. We could use synthetic division, right? So if we were going to do synthetic division, I think we put the negative 3 in the chair. I think that's how that goes. And then synthetic division, right? So we need the coefficients and we also have to get any like missing ones, right? Because we got power 4, power 3, 2, 1, so we're not missing any, right? Any exponent. So then if we take the coefficients, we get a 1, 3, negative 5, 8, and 75. Let's see if they match up. We should get the same result. So again, the first term just comes down. All right, this first one just comes down. On the diagonal, we multiply, so that's going to give us negative 3. If we add, we get 0. We multiply, we get 0. Add, multiply is what, a positive 15? If we add, what is that, 23? That's not a 3. Let's see, multiply is 69, negative 69. It's looking good. And then I think we get 6. That's the remainder. All right. So in one instance, we just plugged it in and we got 6, or we use synthetic division where we put the 3 into the chair and the remainder was 6. So then with the remainder being 6, we're saying that f of 3 is 6. That's the remainder theorem. Hopefully that made sense. So instead of evaluating like we did the first line, we could have just did synthetic division, looked at the remainder, and then that's going to be that function evaluated at that number. I don't know how people discover this, like how we're so distracted in this day and age. Back in the day, they had nothing. Like it was just dead air in their mind. And like I feel like that's how they created a lot of this stuff. But I feel like we're so distracted. Not that we don't have talents and abilities. Like honestly, if it were up to me, I wouldn't have you guys studying this. I'd be like, okay, what is it that you want to study? Okay, let's just focus on that. Like, I feel like school, this is just my personal opinion, but I feel like school is just a ploy to make people feel dumb and like make them, basically coerce them into like submission and like to comply and obey and all that kind of stuff versus a reality where, okay, what are your natural talents? What do you like to do? What if you had all the time and money in the world, what would you do? Then helping people to cultivate their natural talents and abilities. To me, I would rather build something like that because as far if again, my personal opinion, I feel like we have everything that we need to create a utopia as is right now. Like we have the technology and the resources, one for robots to like to automate many of these processes. I know we're worried about like the robot takeover and all that stuff, but you know, it's like, but in the same token, we can still have everything that we have. Like I feel like there's more than enough for every human, it's at least U.S. citizen, to at least have housing, food, and healthcare. Like I feel like we have that. I'm like, why don't we have it? I feel like it's just greed of people in power. But anyway, it's just again personal opinion. I mean, I can go deeper and say some other stuff, but that's just how I feel. Like every time I think about it, I'm like, there's no reason for us to have homeless people like that, other than it's intentional. You know, that's just how I feel. Okay, so you see it here. I'm looking at the time. We got a solid 10 minutes, and I won't keep you past the 10 minutes, but I'm going to finish the stream, God willing. Okay, so that was the remainder theorem. So now we have the factor theorem. A polynomial function f of x has x minus a as a factor if and only if f of a equals 0, right? So if we did the remainder theorem, so for instance, when we do synthetic division, if the remainder is 0, then that x minus a is a factor of that dividend, right? It's so funny. I keep using the word dividend, and I can't shake this thing about like stocks. Like dividend stocks are the best because they basically pay you a percentage of whatever you've invested just for investing with them. So it's like just for having money with that company. There are a lot of companies that do this, and I've used them. I haven't gotten to a stage where I can just leave it in there. But yeah, you just put your money with the company, and yeah, it's trusting the company because obviously if it's a stock, it can go one way or another. But while that company's in operation, they just give you money just for investing in them. So even though I'm using dividend in this context, I can't shake that feeling of dividend stocks. And I never heard of that until I became an adult. Like nobody said anything about that kind of stuff, stocks and how to automate money. Like there are processes. It's not. I still haven't found true passive income, but there are things that we can start working towards where you set them up and you keep reaping the benefits of them. Like real estate is one of those things. That's why society seems like they won't let us get real estate because that's one of the things where when you do it right or you do it a certain way, it becomes an asset and you can actually monetize and capitalize on it and keep getting money from it and just sitting there. I have a colleague right now. His father left him and his sister an apartment complex. This apartment complex generates $20,000 a month, so they just sit there and collect the money month after month, and they live their life. Like that's what I'm trying to work towards. And I was like, okay, well, if I'm not gonna, you know, experiences reap the rewards directly, at least I can pass it on to somebody and teach as many people to do something similar. Like that's just one of the techniques. I mean, there's a lot of techniques where you don't have to punch a clock. I never really encourage anybody to punch a clock. I don't believe in that. Um, yeah. Anyway, okay. I get distracted. So we got a solid like 6 minutes. We'll do this one, and then when we hit the 45-minute mark, I'll let you go. Given that 2 is a 0 of this function, solve this polynomial equation. Okay, so we're given that this is a 0. So let's do I need more space? Yeah, let me give myself some space. Solve this polynomial. Okay. Let's do it like this. I'll just do I'll add a page and I'll go view seamless. Okay, and paper. Grid and paper. Okay. So 2 is a 0. So we're asked to solve. We have this 3x cubed plus 2x squared minus 19x plus 6 equals 0, right? And we're given that 2 is a 0. Okay. Let me just add one more page. Okay. So if 2 is a 0, then let's pass that through synthetic division to confirm. So if we put 2 into the chair, again, that's our 0. Notice the exponents go 3, 2, 1, 0. So every exponent is accounted for, so we can just take those coefficients directly. So then we have 3, 2, negative 19, and 6. Okay. So again, the first term, here, let me, I think this is a little bit better here. So the first one just comes down. On the diagonal, we multiply. So 2 times 3 is 6. Vertically, we add. That's an 8. 8 times 2 is 16. That difference is 3, negative 6. And so we finish with our 0, right? So we've confirmed that it's a 0. Now, so whatever. 5 seconds left on the clock. Okay. Okay. So we started with the degree 3. This next part is called the depressed equation. So that means this is now a degree 2. 3x squared plus 8x minus 3, right? Let's see. Now let's see, can we factor that? So at this stage, if 2's are 0, that means we have x minus 2 times 3x squared plus 8x minus 3 equals 0, right? So we want to see, can we factor that quadratic? So I'm just going to bring down this x minus 2, and I want to try to factor this quadratic into something of this form, where we have x and x. Because this second sign is negative, I know my signs have to be opposite, right? So one has to be a plus, one has to be a minus. Actually, I got to back up. Let me get rid of this and this now. But we want to get it into a form like this. We're looking for two numbers that multiply to give us, do you know what it needs to multiply to give us? Hopefully you are not saying 3, right? We're looking for two numbers that multiply to give us, let's do this color, -9. You have to do the A times C. The leading coefficient is 3, the constant term is -3, so that's where this 9 came from, right? Two numbers that multiply to give us -9 and add to give us 8, and I think that was, let's see, I think it was -9, let me be consistent, -9 and 1, right? They multiply to give us -9, and they add to give us, I guess we have to switch the signs, right? It's going to be 9 and -1. They multiply to give us -9 and add to give us 8, okay? So then what we're going to do, we're going to take this, but rewrite this 8 using those two numbers that we just found, all right? And I think I'm going to use, at this point, I'm going to use a technique called the box method. Box method looks something like this. This is something some students from the past showed me, and I thought about it, and I liked it, so I'm borrowing it. As soon as I finish this, I'll let you guys go. In the upper left-hand corner goes the leading term, which is the 3x squared. Bottom right is the constant, which is the -3. And now on the other diagonal, we're going to take that 8, but rewrite it using those two numbers that we just found. So we have the 9x and the -x, right? Because -x plus 9x is 8x. Okay. So now, if we look at the two numbers on top, what's the greatest common factor? We can factor out, what, 3x? We can factor out 3x from those two. If we look at the two on the bottom, what can we factor out? -1, right? If we look at the two on the left, what do they have in common? We can factor out what, x? And if we look at the two on the right, what can we factor out? It looks like 3 plus 3, right? So then our claim is that it factors, we get x plus 3 and 3x minus 1, right? And you want to do a quick check. I'm watching the clock. You want to do a quick check by multiplying to make sure it works. First times first is 3x squared. Outer times outer is -x. Inner times inner is 9x. So then they add to give us 8x, and last times last gives us the -3, right? So now this is the completely factored form of the dividend. So then by the zero factor property, we set each factor equal to 0 and solve. If we set each factor equal to 0 and solve from the first factor, if we set it equal to 0 and solve, we get x equals 2. The next one is x equals -3, and the final one is x equals 1/3. Right? So then we get these results. Stop. Okay. So then our claim is that these are the zeros. Okay. Let me just, so we can check, we could check by plugging in. Where's my page that I was working on? This one, okay. So we could check that those zeros work by plugging in. Let me just kind of finish this one out and I'll let you go. So again, now if we looked at the type version, they confirmed that the 2 was a 0, so they got the same 0 that we did. Then to find the other zero, solve the depressed equation, all right? So then you factor, we ended up doing the box method and the AC method for factoring. We got the 1/3 and the -3. Okay. Oh, did I? Yeah, I got the 2 right. Okay. Sorry. All right. So with that, I'm gonna let you go. I'm not gonna hold you guys. Sorry. Only announcements again. This is what the top of week 11. So next week we have exam 3 covering chapter 2. So sections 2, 1, 2, 2, and 2, 3. And then after that, and more than likely I'll make that exam available on Monday. The exact same as exam 1 and 2. We'll have 2 sections after that we need to discuss. So about 2 weeks. We have the Thanksgiving holiday coming up. And then all these assignments, you can work on them up until the first week of December. Once we move into that week of finals, these are going to lock out, right? So you want to go ahead. If you don't work on anything else, definitely make sure your exams are whatever grade you want them to be. Just keep working on them until you get them there. Because once we move into the week of the finals, these are going to lock out. Basically, I want the final exam to be the last thing that we do. So once you take the final, you're done. That's it. All right, we're nothing lingering. So all of these assignments are going to be available with only a 10% late penalty until that first week of December. Once we move into the final exam, and we'll talk more about the final as we get closer, but the final exam will be the last thing that we do. So once you take your final, that's it. Okay, guys? Enjoy the rest of your day. I'm going to keep streaming, and I'll see you guys on Wednesday. So now in this example, this is an example on petroleum consumption. Let me check something really quickly. Testing. Yeah, looks good. I'm not going to worry about it. Petroleum consumption. It says the combined petroleum consumption C in quads by a group of the most economically developed countries in the world during 1996 to 2011 can be modeled by this function, where x equals 0 represents 1996, x equals 1 represents 1997, and so on. The model indicates that C of 5 equals 238 quads of petroleum were consumed in 2001. Find another year between 2001 and 2011 when the model indicates that 238 quads of petroleum were consumed. Okay. So basically it's saying we have the combined petroleum consumption, C in quads. So this C is a combined petroleum consumption, right? So then if we set C equal to 238, well, they gave us one of the answers where when x was 5, we got 238. So then we want to find another year that gives us 238, right? So if we set C equal to 238, they want us to basically solve that equation. And they gave us one of the zeros, and that 5 is one of those solutions. Okay, so let's do this. Okay. So we're asked to solve we want to solve C of x equal to 238, right? So then that's going to be, let me suppress my audio. Oh, did it disconnect? Probably. That's fine. Battery is probably low. Internet is unstable. I'm not going to worry about that right now. Okay. So then testing. Let me make sure. I think you guys can still hear me though. You should be able to. Testing. Okay, looks good. Let me check. Is it going to let me? It's not going to let me. I'm going to have to just go with it. Okay. So then 238. All right. So then let's write out this function. Let me see. I know I'm going to run out of space. So I'm going to do it like this. 0.021 x cubed minus 0.973 x squared plus 11.347. I think there's an x missing from there. Okay, I'm gonna assume. I think an x is missing from here. With this x because I think it's missing. Plus 202, and now I'm out of space. Plus 202.0 0.965. So give me a moment. I wrote it like that just because, you know, I knew the way I write, I wasn't going to have enough space to get that to fit on the line. So let me just go like this. Okay. So now, so what we did, we said C of x equal to 238. So if we subtract 238, all right, we'll have 0.021 x cubed minus 0.973 x squared plus 11.347 x. I'm just going to use my calculator. I guess I can use that one. Oh, absent. Yeah, I got to track down these students. I think I need to do this today. Give me just a moment. Pulling up my calculator. This one. Cool. Reload and refresh. Okay. Let's see. So I want to say that 202.965 minus 238. 35.035. So we get a negative 35.035 equals 0, right? So we subtracted 238 on both sides. So now we were given one of the zeros when x was 5. So if we take that 5 and do synthetic division, we should get a remainder of 0, right? Notice the exponents go 3, 2, 1, 0. So if we take the coefficients, we get this 0.021, negative 0.973, 11.347, negative 35.035. If we do synthetic division, we should get a 0 remainder. So the first term just comes down. If we multiply, what is that, 105? Here, let me just, 0.021 times 5, 105. Okay. We add, here I'm just going to say that answer plus a negative 0.973, 868, negative 868, negative 0.868. Then I'm going to say that answer times 5, negative 4.34. Okay. Then I'm going to say that plus 11.347. We get 7.07. No, 7.007. Then I'm going to say that times 5, 35.05. Okay. So we've confirmed that 5 was indeed a 0. So now, since we started with the degree 3, at this stage we are now degree 2. So this is like x squared minus x plus that thing, right? So we get this. So we want to solve this quadratic, right? Instead of just trying to factor this, we're going to use the quadratic formula. Again, quadratic formula. The negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks. And it was all over by 2 a.m., right? So then we would say negative of negative b, or negative b in this case, double negative becomes positive. So we get 0.868 plus or minus the square root of 0.868 squared minus 4. Our a is 0.021. Our c is 7.007. Okay, I'm just using quadratic formula directly. Over 2 times our a is 0.021. Okay, so let me see. First I'm going to do the minus. So let's see. The top, we got this 0.868 minus square root we got 0.868 squared minus 4 times, let's see, does that, cool, because that's what I wanted to do, okay. 4 times 0.021 times 7.007. That closes off the square root, that closes off the top. I'm going to say divided by 2 times 0.021. Okay. So now when I use the minus, I got 11, right? So one of the results is that x equals 11. And then if I change that minus to a plus, let's see what happens. I get 30.3 bar, right? Now, it asks us to find another year between 2001 and 2011, right? So if 0 represents what, 1996? So 5 is what, 2001? So 11 years later, so 2007? Because I think 30 goes outside of this range, right? So then 11 years later should be 2007. It was another year in that range where the output was 238. Okay, hopefully that was okay. Let's go paper, get rid of the lines. And let's go view. Okay. 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 So then they did their division. They got the same thing we got. Then they use a quadratic formula. They got 11 or 30.3 bar. Since 11 is between 5 and 15, 2007 was another year where we use that amount of petroleum. Okay. We're almost to the end. So this next part is on the rational zero test. So given a polynomial function with integer coefficients, it says with integer coefficients, okay? And the leading coefficient and the constant term are not 0. And P over Q is a rational number in lowest terms, that is a 0 of the function. Then P is a factor of the constant term and Q is a factor of the leading coefficient, right? So the rational zero test, what happens is basically you say that constant over the leading coefficient, and you list out all the factors of that ratio. Any rational zero of that polynomial function is going to be somewhere in that list, right? So find all the rational zeros. So I think I'm gonna give myself some space on this one, so I feel like I just might run out of space. Let me add one more page. And I'm gonna change my view back to seamless and paper, line paper. Okay. So find the zeros. I just can't help. I'm gonna go ahead and first, let me just get a copy of this. So we have f of x equals 2x cubed plus 5x squared minus 4x minus 3, right? We're asked to find the zeros, find all rational zeros. So now the rational zero test, the P over Q, if we say P over Q, the P comes from the constant term. So the factors of -3 are plus or minus 1 and plus or minus 3, right? Those are the factors of the constant term. And then in Q comes from the factors of the leading coefficient. So in this case, that's just going to be plus or minus 1 and plus or minus 2, right? So then what we want to do is do all the combos of the top with all the combos of those factors from the top with all the factors of the bottom, right? So if we say 1 over 1, we get plus or minus 1. 3 over 1 is plus or minus 3. And then we can do plus or minus a half, and then plus or minus 3 halves, right? So what we're saying, this list that we just generated, if this polynomial has any rational zeros, all the possible rational zeros from this polynomial is going to be somewhere in this list, right? So then so if we're trying to find the zeros, this list is a great starting place, this rational zero test. So we're just going to kind of take each each candidate and passing through synthetic division, right, until we find a result. I think we might. Let's just see what happens. So first, we're gonna start with 1, since 1 is one of the candidates for 0. All right. So then let me see. If we look at our exponents, 3, 2, 1, 0. So all the exponents are accounted for. So we can just take the coefficients. So then we're going to have 2, 5, -4, and -3. Okay. So then the 2 comes down. 1 times 2 is 2. 5 plus 2 is 7. That multiplies the 7. That adds to 3. That multiplies the 3. And that adds to 0. So we got lucky. We found a 0 off the rip. So 1 is one of our zeros. So now we started with a degree 3. At this point, it's a degree 2 polynomial, right? So then, can we just factor that? Does that factor? Let's see. Can we just factor that into something of this form? Let me see. Actually, okay. I'm gonna do the AC method again. Two numbers that multiply to give us what? 6 and add to give us 7. So two numbers that multiply to give us 6. Be aware that 6 is what? 2 times 3? The multiply to give us 6 and add to give us 7. So we're going to go through all the factors and we're going to stop on the line that adds to 7. First is what? 1 and 6. And I think those are the two numbers that we're looking for. So then I'm going to use the box method. All right. So the box method. Upper left-hand corner goes a leading term, which is the 2x squared. Bottom right is the constant. And then on the other diagonal, we take those numbers that we just found. So we have an x and we have 6x. Okay. What can we factor out of the 2 on top? They both have x in common. What can we factor out of the 2 on the bottom? They both have 3. What can we factor out of the, move this around again. I'll just move it like here. What can we factor out of the 2 on the left? It looks like 2x. And what can we factor out of the 2 on the right? Is a 1. Right? So it looks like that factors into 2x plus 1 and x plus 3. Okay, so our claim is that the original factors into, if the 1 is a 0, the original factors into x minus 1. Looks like we have this 2x plus 1 and x plus 3. All right? So if we want the 0, so now we got it in completely factored form. Again, we were already given, well, we found 1, 0 fairly quickly. If we set the middle factor to 0 and solve, we get a -1/2. Notice this in our list, and we also get -3. So our claim is that these are the zeros. I'm going to shrink this down to 1 page. Okay. So let me do like this, like this. Actually, before I do that, oh no. Let me move this. And let me actually shrink that down separately. As you can, I saw it just looked like it could fit like here. Then that way I don't have to shrink all of it. Then this can go like there. Okay. Okay, let me get rid of this. Let me change my view back to single page. We got this in paper. Okay. Yeah, so we got lucky. We found that first 0. The hardest part about finding zeros of polynomials is finding that first 0. But once you find it, then you know it gets exponentially easier from there, much easier. But sometimes finding that first 0 can be kind of a challenge. We got 1, a -1/2, and a -3. Okay, so the rational 0 test, we did all the combos. We got the same things that we got. They found that 0. Okay, I think we got those results. Okay, we didn't have that much more. It's only like about another 15 minutes or so. On that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Peace.